Alright, so I will be presenting on Neuralink. So what exactly is Neuralink? Neuralink is a neurotechnology company founded by Elon Musk in 2017. The company aims to help people with neurological conditions such as cerebral palsy and paralysis become independent with the use of an implant called the Link. But the company also hopes to assist those with mental disabilities, such as Tourette's or mental illnesses. Musk has previously founded other companies such as SpaceX, Tesla, The Boring Company, where he marketed his Not a Flamethrower product, and OpenAI. The company would allow people to use a BMI or brain-machine interface, enabling them to communicate telepathically through text within the Neuralink app, or even give them the ability to download their human consciousness onto a computer, though that is a far stretch. In addition, Musk seeks to pursue a transhumanist goal. By using the implant, he hopes that humans can grow alongside competitive AI demands. Since markets are currently being plagued by AIs taking over jobs and increasing competition between humans. One example of this is Amazon employees being replaced by the AI in the Amazon grocery store. Some of the companies that Elon Musk has founded, the one in the upper left is SpaceX, and the one in the upper right is his Tesla truck model. The one in the middle is by his company OpenAI. It is on one of the pages to apply for a job at his company. And then the other two are by the Boring Company, one which is his flamethrower. So then, how does the link work with the brain? Well, first and foremost, a general understanding of the brain's biology is required to interpret the link's functions. The brain has around 86 billion neurons responsible for communicating with the body by transmitting information through chemical and electrical signals and synapses. Although there are various types of neurons, the basic model for a neuron is composed of soma, which is a cell body, dendrites, axons, and axon terminals. Neurons carry information by first receiving information from other neurons. The soma receives this information from the dendrites and transports it through the axon as nerve impulse or as action potentials with electrical signals. From there, a synaptic gap located between the axon terminals and another neuron's dendrites transports the impulse into the other neuron. This process repeats across neurons. By using the link implant, electrodes are placed in proximity to neurons. The implant then detects nerve impulses in the brain and translates them into data that can be decoded by a computer. Tracking and analyzing the information within a neuron is crucial for the possibility of one day potentially manipulating neurons with the link so the user can experience a sensation. For people with neurological conditions, this could give them the perception of taste, touch, or smell. People with other conditions could gain stability or even full control over their conditions. For example, people with cerebral palsy could reduce the amount of movement that they have, or they could increase the amount of control they have over their own movement. The link's engineering. So, although the engineering that is put into the link is complex, it can also be simplified. The link's previous design was changed to the design of the one on the right. This allowed Musk seem to create a more compact and less damaging implant than the one shown on the left. The implant is roughly the size of a quarter, and during this year's Neuralink summer update, Musk had an example of one of the implants being used at the company. Long and thin electrode threads made from metals and polymers hang on an approximate inch away from the implant. The threads themselves are only the size of 1/10 of a human hair's cross-sectional area. The threads are to be flexible to ensure that they safely enter the brain's tissue without any major damage to the brain tissue or to surrounding blood vessels. The surgery for the implant has to be precise, leaving only 2 millimeters of space in between the width of the skull, which is a total of 10 millimeters, and the width of the implant, which is 8 millimeters. As you can see, last year's design would be far more damaging to embed into the brain and the skull than this year's designs. So, Musk aims to make the implant surgery as non-invasive as possible. His goal is to have a quick, precise, and easy surgery that requires minor anesthesia and is similar to other walk-in surgeries, such as LASIK eye surgery. However, when Musk initially announced this, there was no surgical robot capable of the precision his neurological surgery required, and much less a human surgeon that could possibly achieve it. Therefore, he had a surgical robot designed in California that would fit the criteria needed for the currently invasive surgery. The surgical robot uses depth tracking to find the precise location where electrode threads must be embedded into. The robot can be used automatically and insert 6 electrode threads at a time into the brain, or it can be used with control of a surgeon. The robot is still currently a prototype, but it has been used in Musk's pig surgeries. On the upper left is an image of Musk's surgical robot. In comparison to a corridor, the tip of the needle of the surgical robot is far thinner than the width of a penny. The part that is actually being embedded into the brain is the one where the arrow is, so it is very tiny, and that is only a fraction of a penny's width. So the following video is an example of the electrodes being implanted into a pig's brain from the Neuralink Progress Update Summer 2020 live stream. I do advise that if you are queasy or uncomfortable with surgery footage, you would most likely skip this part in this section. But it is a very informative narration by Elon.
So this shows you at sort of close-up view, which I think is actually not too gruesome, of the electrodes being inserted in the brain. And if you look closely, you'll see that it's a little counterintuitive that if the electrodes are inserted very carefully, that there is no bleeding. And so if you have very tiny electrodes, and if they're inserted very carefully, so that the robot actually images the brain and makes sure to avoid any veins or arteries, so that the electrodes can be inserted with no noticeable damage. So you will have no noticeable neural damage.
Neuralink's current progress. The Link implant has been successful by far, though the success is restricted to animal testing. The live stream also included segments on the pigs and their brain implants, some of which still had the Link implant, some of which had gotten it inserted and taken out, and some who even managed to have multiple implants inserted into their skulls. One particular pig was used to show the functions of the implant 2 months after the surgery. The implant detects Gertrude's nerve impulses when her snout touches something and then translates it into data a computer can read. Musk further mentions that the pigs are healthy and normal. And as for their environment, another video titled Animal Care at Neuralink demonstrates the care and effort put into maintaining happy and healthy animals. The video depicts a collaborative work environment where engineers and veterinarians alike contribute to giving the pigs the best treatment available while they are being tested. The following is a recording of Gertrude's snout and the information that is being translated into the computer.
Gertrude, thanks for coming out. So the beeps you're hearing are real-time signals from the Neuralink in Gertrude's head. So this Neuralink connects to neurons that are in her snout. So whenever she snuffles around and touches something with her snout, that sends out neural spikes, which are detected here. And so on the screen, you can see each of the spikes from the 1,024 electrodes. And then if she snuffles around, touches her snout in the ground, or you kind of feed her some food, pigs love food, then you can see the neurons will fire much more than when you're not touching the snout. And that's what's making the beeping sound. All right, cool.
This video depicts the environment in which the pigs are tested. The Neuralink staff seems very dedicated towards their animals, And even the engineers are passionate about making an implant that is comfortable for the animals at Neuralink.
Extremely attached to the animals.
I definitely get attached to the animals.
Yeah, they're really cute.
We want to be more kind. We want to be more humane. People coming into the field now are really pushing that.
I'm one of the people who makes the devices using my hands. I'm constantly thinking that this is gonna go into Barbara, or this is gonna go into Cleo, and we know their names. We've seen them.
Our animal behavior team is fantastic. My job's so much better because I can rely on their expertise.
One of my jobs is to help design behavioral plans and training plans for the animals that we use in behavioral research. Make sure that the spaces that they're in are comfortable and designed in such a way to express that full behavioral repertoire.
I oversee all facets of the animal care program, from the day-to-day husbandry, food, water, provisions for these animals, to ensure that these animals are always looked after to the best of our ability.
So we actually have a committee here that we've developed that meets regularly, talks about ways that we can try to prevent compassion fatigue, so that every day when we come in, we have the energy that we need to provide good, loving compassion to the animals that we work with.
Pigs are a model that actually approximates humans in some interesting ways in terms of size, biomechanics of the skull. They're very adept at exploring their environments, using their senses, their sense of touch with their snout in particular. We can tap into that part of their brain and decode those intentions.
It's totally amazing to see what they're able to do with training, all with positive reinforcement.
Positive reinforcement is where you offer an animal an opportunity to form a behavior and be rewarded for it if they choose to participate in it. We do give them the option of not participating. We'll do reinforcement preference testing.
And if you look into any other field where animals are looked at, whether that's the food industry, the pet industry, you're not going to find any other area where there's multiple dedicated veterinarians, veterinary technicians, animal care, behaviorists, all looking at an animal every single day.
I got into this field probably as an inspiration from my sister, who is on the autism spectrum. It made me look at all life forms that were struggling and challenged to have their own voice heard. And so I wanted to be in a position where I could bridge that opportunity to communicate with the world.
I really feel that Neuralink supports animal welfare and allows us to have a voice for them.
I feel really proud that I get to be part of making their lives and that contribution better.
Conflicts and concerns for the future. Although Neuralink is demonstrating great ethical support toward their animal testing field, there are numerous other factors that the company and the implant could both have ethical conflicts with. For one, mental privacy is an issue that would result in the release of the implant. Consumer privacy could be invaded by hackers, third-party companies, and viruses. Viruses such as Trojans and malware. The implant could also be subjected to privacy breaches. This would be a significant issue, as Neuralink would record and be responsible for the neurological and biological information of a consumer. Mental privacy could also be vulnerable to ad exposure and exploitation, worsening the impact of targeted ads if the implant is developed up to Musk's expectations. The Neuralink company may also change the way humans work with their current environment. Most transhumanist ideals for the Link implant are caused by the increased competition of human and AI jobs. He fears that one day humans will be surpassed by AI, so his goal is to extend human capabilities so humans can evolve alongside AI, which is not the most ethical human augmentation. By merging humans and technology, the line between what defines humans would be forever changed. People would be more attached to technology and possibly social media than what they already are now. Musk argues that humans are already part of technology and that they should look forwards to advancing the progress of human evolution. But if the Link implant is designed to change what people perceive, then a matrix-like disconnection from reality may occur within society.